Aiming, vectors, angles. Let's dive in. Today we're building an aiming indicator using vectors and angles, specifically Unity's arctan2 command, Euler angles, and a bit of trigonometry. We'll pick up right where we left off in the last episode with our direction vector ready. So let's dive into the project. Let's go ahead and create a new script for it. In this script, we'll update both the position and orientation of the indicator based on our direction vector. But before we do that, let's revisit the drawing board for another vector essential, finding a vector's angle. If you remember, in a past video we talked about polar coordinates. That coordinate system defines a position by its distance from the origin and an angle. We'll do something similar here, only now we have the distance and need to calculate the angle itself. Let's say that this is our direction vector. We want to find its angle, but the first question is angle relative to what? Direction only has a meaning in the context of a coordinate system. So, in the same spirit, an angle needs to have a reference axis. The standard reference is the positive x-axis, so that's what we're gonna use today. Now consider the triangle formed by the vectors x and y components. Here's the trick. If you know the opposite and adjacent sides of a right triangle, the angle is related to their ratio, that is the tangent of the angle. Tangent of theta equals y over x. To get the actual angle, we need the inverse tangent of that ratio. So theta is equal the arctan of y over x. We can do this easily in Unity using mathf.atan, which means arctan or inverse tangent. Sounds simple, right? But there's a teeny tiny catch there. This version doesn't account for which quadrant the vector is in. For example, a vector pointing left and up and a one pointing right and down could give the same result, because their y to x ratio is the same. This happens because the calculator assumes that x is always positive. If x is negative, you'll get the wrong direction, so you'd have to manually add 180 degrees when that's the case. Luckily, Unity has a better tool for this exact purpose. Introducing mathf.atan2. This method takes two arguments, both y and x, and handles all the quadrant math automatically. So no extra adjustment needed. Just feed it the y and the x and you'll get the correct angle ready to use. Now that we have all the engineering knowledge required for this example, let's apply what we've learned and create the aiming indicator. We'll begin by creating our variables. We set the distance from the player, a variable for the calculated angle, and a key to destroy the indicator. For example, when we release mouse 1 after aiming, we want the indicator to be destroyed. You could serialize the key to destroy and distance, or you can use setter methods like I do. Next, we take the aiming method from the player script that we programmed in the last episode, so we can track the mouse position locally. Now it's time to apply the knowledge we acquired today and write the direction setter method. First, we use mathf.arctan2 with our directions x and y components to get the angle. 50 house points if you can write in the comments why this works even without normalizing the mouse aiming direction. Then, we set the new position using x equals the distance from the player times the cosine of the angle, and y equals the distance from the player times the sine of the angle. This moves the indicator in the direction of the cursor. If you're unsure why this works, check out my polar coordinates video. It explains this in detail and it'll be the first link in the description. Lastly, we do a similar thing where we update the orientation by using transform.eulerangles equals to the x, y, and z rotations in degrees. The calculated rotation is in the z-axis. Maybe I'll make a short video explaining why that is, so stay tuned. We also need the scaling factor of mathf.radian to degrees because the angle we have is in radians and this method requires degrees. Now all that's left to do is call this setDirection method from the update and listen for the designated key to destroy the indicator when we stop aiming. If you opted for setter methods, remember to add them to your script. This wraps the indicator logic part, but we also need to actually create it when we're aiming. So let's do that now. We create a method for instantiating the aim arrow. We instantiate it in the player's position. See if you can tell why we do that without needing to apply the offset we talked about earlier. Another crucial thing to notice is that we're setting this aim arrow as a child of the player. By doing this, we're making sure that the origin of the arrow is the player's position, and not some other place in the map. With that said, this can also lead to a small bug that we will fix very easily. Then we set the relevant parameters of the distance from the player and the destroy key. The last step, of course, is to call this aiming arrow method within our shooting method, or any other method that requires aiming. Now the indication works, but some of you might notice a weird thing when the player faces the other direction. The indicator is opposite to the cursor. I'll give you a few seconds to try to figure out what happened there. Remember we instantiated the indicator as a child of the player? Well, when we flip our character's facing direction, we also flip the aiming indicator with it, which may sound correct, but in reality it isn't. So to fix this, all we need to do is to multiply the distance from the character by its facing direction sign. This will make sure that the orientation is correct as well. And believe it or not, we're good to go. Some of you might notice a slight angle offset. That's likely because your sprite isn't aligned with the x-axis by default. If that happens, go into your sprite settings and rotate it to align with the x-axis. If it already aligns, you're all set. After we forget to set some of our parameters and then we fix that, and then we forget another thing and we fix that as well, we finally have our functioning aiming and shooting systems. Yeah, and that'll do it for this video. As always, I hope you liked it and learned a lot from it. If you did, please consider leaving a like, comment, and subscribing. I would really appreciate that. In the next video of the series, we'll explore the dot product between two vectors and how to use it to write powerful logic for our games. Thank you all for watching, and I'll see you in the next one. Cheers, guys!